hyperbolic function. In grade 10, you had it as y is equal to a all over x plus q, of which we had only two parameters. The value a, if a is greater than 0, it's a decreasing function. And since it's a decreasing function, you find the reciprocal graphs in the first and third quadrant, like so. Like this one, right, of the Cartesian plane. Yes, like that. And then if a is less than 0, it's a negative, so the function is an increasing function. And the reciprocal graphs will be found in the second and fourth quadrants of the Cartesian plane. So they will be like that, right? So when we are talking about these quadrants, these are quadrants made up by the asymptotes of the graph of the function. So remember, a reciprocal function has got a vertical asymptote and a horizontal asymptote, right? So the value of q affects the vertical shift of the graph. If q is greater than 0 or positive, the graph moves up. If q is less than 0 or negative, the graph moves down. Okay, moving on. Now let's do some drawings of these graphs from grade 10. So in this example, we are going to sketch a number of graphs. We're going to start with the parent graph of the reciprocal functions, which is f of x is equals to 1 all over x, right? And then the asymptotes of this function is the vertical one is the y-axis, the horizontal is the x-axis. Now let's draw g of x, where our a is negative. So you see it's found in this second and fourth quadrants. And then if we have if we increase p, you see if we increase q, the function of h of x there, you see that it shifts upwards. And then if we say a is negative, the reciprocal function, the parent one, is reflected about the x-axis, and then it is shifted, right? And then it is shifted 1 unit downwards. Can you see that? So this is just a summary of the things that you did in grade 10. Now let's move on to grade 11, where we introduce the parameter p. So in grade 11, we introduce an extra parameter p, and this one has got a vertical shift. The other has got a horizontal shift. So the other parameters will still have their effect, like value of a, it affects the shape of the graph, right? How does it do that? If a is greater than 0, the graph is decreasing function. And then the graph reciprocal function or graphs are found in the first and third quadrants of the Cartesian plane. And if a is less than 0, that is negative, the graph is an increasing function. And the reciprocal graphs are found in the second and fourth quadrants of the Cartesian plane. Now looking at the parameter p, so the parameter p affects the horizontal shift of the graph. If p is greater than 0, that is, it is positive, the graph shifts p units to the left. And if p is less than 0, that is negative, the graph shifts p units to the right. It might be confusing, but you need to know that. And then the parameter q, so this is parameter q, not p, right? So the parameter q, if q is greater than 0 or positive, the graph shifts q units up. And if q is less than 0, negative, the graph shifts q units downwards. Let's draw some graphs to see the effects of p on the reciprocal function. Right, so here we do an investigation, right? We're going to sketch the graphs. We start with the parent graph, f of x is equals to 1 all over x, and it looks like this, right? And then we draw g of x, where we've introduced both parameters. we increase them by 1 unit. You see it shifts to the left 1 unit and lifts out, shift upwards 1 unit. And then we put all the parameters to be negative. It is reflected about the x-axis. It shifts to 1 unit to the right and 1 unit downwards. And then we increase the parameter p by 2, increase q parameter by 2, make the a parameter -1. It is reflected about the x-axis. It is shifted 2 units to the left, and then it is shifted 2 units upwards. Okay, let's do some examples where we deal with one graph at a given time. Right, steps first to sketch the hyperbolic function. So we first have to write down the value of a, that is our function a. Remember, you have to, the a will dictate to you how your graph will look like. So if a is greater than 0, it's a decreasing function. A is less than 0, increasing function. Step number 2, right. Step number 2, you see that we need to find your x-intercept. You put y is equals to 0, and then you solve for x. Your x should be equals to a all over cube minus p. Step 3, we find the y-intercept. So your x should be equals to 0. You put x is equals to 0 into the equation and you solve for y. So your y should be equals to a all over p plus q. And then step number 4, we are going to find the asymptotes. This equation, remember, there was 2 asymptotes, the vertical and the horizontal asymptote, right? The vertical asymptote is the 1. Vertical asymptote is the 1, so we call this one the vertical asymptote, and this one is the horizontal asymptote. Okay, moving on, step number 5, lines of symmetry. The first line of symmetry is y is equals to x plus p plus q. The second one is y is equals to negative open bracket x plus p plus q. Okay, moving on. So now we are going to be using these steps to plot a hyperbolic function or a hyperbola, right? A hyperbola, right? So now example number 1, right? We are going to sketch the graph of f of y is equals to 12 over x minus 4, right? So we are going to say step number 1, our a is equals to 12, so a is greater than 0, so it's a decreasing function, right? Step 2, we find the x-intercept. When we find x-intercept, remember we put y is equals to 0 and we solve for x. In this case, there are no real solutions, so no x-intercept. Step 3, we find the y-intercept. We put x is equals to 0 and then we solve for y. In this case, our y will be equals to -3. So our intercept is 0 and -3. Step 4, we find the asymptotes, right? Our asymptotes, remember, it's x is equals to -p, which is, we substitute where there is p, we put -4. So the vertical asymptote is x is equals to 4. And then we put in place of the horizontal asymptote y is equals to q, which gives us y is equals to 0. And then step 5, we find the lines of symmetry. So it's all a matter of substitution, knowing the equations and just doing the substitutions. So you substitute for p and q in both of the equations, and then you see that the equations will be y is equals to x minus 4 is one equation, and the other one will be y is equals to -x plus 4 when simplified. Okay, after doing this, now we can draw the graphs on a Cartesian plane. We are sketching it. Remember, it's not drawn to scale, right? So we are going to right. So we plot our x and y intercepts, of which we don't have the x intercept, we only have the y intercept. We put the asymptotes. Then, guided by the parameter a, we know that our graph is in the first and third quadrants of the asymptotes, and then we draw our lines of symmetry, and you will be done. Right? Let's do another example. Right? Example number 2. Sketch the graph of y is equals to negative 12 all over x minus 4 plus 2. Right, step number 1, our A tells us that this is an increasing function and the graphs are in the second and fourth quadrants. Step number 2, we find the x-intercepts. We put y is equals to 0. And then we solve for x. Solving for x. Our x will be, so first we subtract 2 from both sides and we multiply both sides by x minus 4. And then we isolate x. X will be equals to 10. So our x-intercept will be 10 and 0. Then step 3, we find the y-intercept. Remember, we put x is equals to 0 and we solve for y, of which in this case our y is going to be a5. Right, and in y-intercept is 0 and 5. And then we find the asymptotes, which is step number 4. We find our asymptotes. X is equals to negative p, which is x is equals to 4. And then the horizontal is y is equals to q, which is y is equals to 2. So we have our vertical asymptote and our horizontal asymptote. Step number 5, we find the lines of symmetry. Right? Lines of symmetry, which is going to be, the first one will be y is equals to x minus 2. And the second one is going to be, we substitute where there is p, we put negative 4, where there is q, we put positive 2. We simplify. It's going to be y is equals to plus 2 plus 6, correct. Right, moving on. Now we can draw the graph. So we on our, right, we don't have to put anything to scale. So we're going to plot the x-intercept, which is 10, 0, and 5. And then we plot the y-intercept. So we plotted the y-intercept first, which is 0 and 5. And then the x-intercept, 10 and 0. And then we draw our asymptotes and we label them. Right? Now remember, we know that the graphs are going to be in the second quadrant and in the fourth quadrant, and you can see the x-intercept is in the fourth quadrant and the y-intercept is in the second quadrant. So when you draw your graphs, make sure that they pass through those points, like so. Right, first graph and second graph, and then we draw our lines of symmetry. There we go. Remember, the lines of symmetry always pass at the point of intersection with the asymptotes. Now let's look at a different example. Now we are going to be given a graph, and from the graph we are going to determine the equation or the function. Right? So we are given a graph. There we go. So you see we have the asymptotes clearly labeled, which will definitely assist us. You might even have your lines of symmetry, and as to come up with the graph, you must be able to do that, going and come back. Right, so here you write down the equation, which is y is equals to a all over x plus p plus q. Vertical asymptote, we are told it's x. Remember, it's x. Right. Our asymptote here, remember, it's x minus supposed to be x minus p, right? So we substitute where there is p, we put 2, and then our p, we solve for p, of which p will be equals to 2, right? And then we substitute, we put back that value into our equation. It's going to be y is equals to 9 all over x plus 2, since we have found the value of q. Now, using the horizontal asymptote, we can find the value of q. Remember, horizontal asymptote, it's y is equals to q. So in this case, our q is negative 3. So we rewrite our equation. It's going to be x plus 2, right, minus 3. Now we need to find the value of a. We are going to take any point which is found on the graph. So in this case, you can see the graph passes through the origin, which means we are going to use the origin to find the value of a. So we are going to say the graph passes through the origin, and we say if x is equals to 0 and y is equals to 0, we substitute those values into the equation and we solve for a. So we solve for a. So our a will be, so we have to isolate it first. It's going to be, our a will be equals to 6. So now, therefore, equation of the graph is y is equals to 6 all over x plus 2 minus 3. I hope you were able to see how this equation was done and all these examples that we did, and you will be able to attempt questions. And if you have got problems, don't hesitate. Later on, when we finish, we are going to be attempting, when we finish all the functions, we are going to look at some exam questions. Okay, so look out for that video.